Happy to see all of you here today. This is the last presentation of the day, many good presentations today. Some of more technical, some of a little more less technical. I try to be light, so I'm not going to be very technical. I'm talking about how industrial data ops can transform manufacturing. We have heard a lot of today about information modeling. What I like today is that we have a lot of talk about information. We are not talking about any more data. We are not talking about protocols. We are talking about the next level. If we talk about harvesting value and wisdom out of the data, you know that pyramid of data, information, knowledge, and wisdom. And there is a hard data layer on the bottom, but you need also, if you want to have information from out of the data, you need the soft data, and you need people with the competence. We have heard today great example from the Danone that there was this kind of service already that the people can, the subject matter expert can go and pinpoint those data points from their perspective and share the competence what they have. So this was very delightful. And we had a real demo here. We had a machine and an actual physical device that we saw the data here. I like it more that kind of in the future. But now, last one, transforming manufacturing with industrial data ops, improving and driving efficiency, quality, scale, and innovation for manufacturing companies. Let's see first, what does the manufacturing company looks like as a basics. Even if you are producing cars or chocolate or food, you usually come external orders comes in to the resource planning. You plan resources, you plan your material usage, you schedule the operation and work order, and then you say good to go to the operation level, and there you monitor efficiency, you monitor traceability, etc., and you say control systems to drive the recipes, and eventually the equipment level you get the product out. So pretty simple from this perspective. Of course, there is supply chains and other variables in this picture, but from the manufacturing, from the factory point of view, this is pretty much of it. Okay, we have heard a lot of today about information modeling and the variation of the plant systems, and that is a huge challenge for industrial companies. The lowest level, more you go down, the variation increase. In the equipment level, you have a lot of vendors, you have a lot of protocols, etc. So one issue is the protocol stack mapping and getting that interoperable in the technology-wise, but also in the information-wise. We have different machines, but we have also different operators, different ways of operating. The machine today that you buy from the same supplier has a different SLA for availability than the machine 10 years ago. So you have to actually not version the protocols or the data stack, but also the definitions of the data. But if we talk about the protocols, we know that each of these layers has a little bit different background. OPC UA has been, or OPC, from classic to the UI, has been doing a great job to harmonize data on this lowest level, because that has been the most problematic. But I think there was some presentation today where we saw some percentage of how much OPC devices are today discoverable and etc. So there is huge amount of still implementations, not with OPC UI, not with standardized data models or information models. So this is the reality. And if we look this from the data connectivity perspective, actually here I have to say thanks for George Forde from Black Hawk Automation from Massachusetts. He has been sharing these slides for me for this event, so thank you, George. If we look at this dilemma from connectivity point of view or data dependency view, we saw this is a small site. You have different kind of connections and dependencies between the systems. Then you have a bigger site, you have more connections, more and more connections, and this costs money. If you want a new data point in your cloud or vice versa, you want to have some of the analytics from the cloud to the device level, you have to do a lot of integration. So in practice, what you do, you stitch these layers in a linear, traditional integration process. And this costs money. So you have a lot of different kind of expert stitching these different layers together to get those working. If you make changes, for example, adding new machine, you have to stitch that back again, and then you increase that money. So if we think about the manufacturer, it's my asset, my money that I'm paying off. Of course, the service providers are happy to take that. But this way of approaching, actually, this linear integration takes a lot of time and money. So both are valuable. Time is valuable. We want speed. We want to be more efficient with our data-driven scale of the data-driven in our business. And of course, we want to save money. So this is cost and time. And in addition, if we look this from the information point of view, the gap between the data consumers is quite huge. And this is not only challenge in money and time-wise, but only in the information-wise. Language is simple, you can have an OPC UA interface from device from Japan and different device from Germany. They might have a different language. Well, okay, I can use language model to tackle that one. But then vocabulary, what does it mean? What is machine for maintenance person? What is machine for SCADA person? Machine for the SCADA person can be filler, but machine for the maintenance system can be pump. And for the SCADA, the pump is component. So the vocabulary, what you are talking about, how do you see the world, is actually pretty critical. So companies are even struggling, even if they have same naming conventions, they are talking about a little bit different things. And it's the consumer. We have to think about the person who is actually looking for that information. How does it and he or she sees that? Of course, there's this context. So how do I want to see this KPI? From which perspective? And there is the audience. So that is the crucial here. We have heard today a lot about data modeling, but what I would like to today also in this presentation to emphasize is the people. They are making the actual money and the operations. I think one great example was that technology is great, but make people love it. Participate them, make them be proud of the technology solutions so that they have. Make them empowered by the data. And cadence. So you have different kind of systems requiring different kind of cadence of data. Some needs to be real time, some needs to be event, some needs to be buffered, etc. It's same kind of like packaging. If you want to order a package from Amazon, if you can choose the cadence of the package. If you are not in a hurry, it can wait and you can bundle more packages into the same pallet and send it into Finland. But if you are very in a hurry, they will send you only that package. Of course, the price will be different. But in addition to the data challenges on those linear integration, the information and its context is very, very important. And bridging the gap between the consumers. So the producer needs to know where the data is used for. And for this purpose, industrial data ops is highly trending practice. In a sense, I will be quite quick in here. DevOps, combining development and operations in a single practice for speed. Data ops, it's a DevOps approach for managing data pipelines, and maintaining them. And industrial data ops focus especially on the industrial sector, where it has this kind of unique features, and it focuses also bridging the gap between the IT and OT that we have also today speak about. This is a definition of industrial data ops. So it's a practice of people, process, and technology. And people again here is the key. We need to have those people together. The data producers must know what the consumer wants. The data producers must understand the dependencies of the changes on the data systems. Jukka said very, very well that start with modeling. Model your consumer. I think that's a kind of more and more common that 10 years ago you just wanted to grab everything. You know, we have this kind of so variety of systems and hard to get any out of this data. Let's just grab and take all of this data into single platform where we have time to actually run this. But in the same time, when you take all the data into the single platform, you actually increase the gap for the data producers and the soft data that those specialists have. So industrial data focus to bring people together with processes and technologies suitable for the company. It aims to help with efficiency, automation. I would say that how many times that we have great information models. OPC UA have great information models. PackML is very used, for example. But we have heard today also that those are not always like fitting into the exact point of the organization. But utilize information models. There's a great information models existing. And your system has already namespaces and structures. Your historian have, your OPC UI server have, your maintenance system have some kind of structure. So automate, utilize those existing namespaces that you have in the field already. You don't have to invent everything from the scratch. And go from the data infrastructure to the information infrastructure. Quality perspective, data producers need to understand better the dependencies and how the data is used. And of course, the data producers should take the control of the data they produce. I think that's the only way to do it. They need to productize the data for the organizations. Scalability, decrease dependencies through information chains. I guess everybody have seen some point some like very, very big dependency chains in these data pipelines. And with industrial data ops, use cases are more rapidly deployed with lighter maintenance. And innovation is one that when you actually productize the data, bring it that easily available, innovation happens. So people, if you are operator on the plant floor, we bump many times these days this kind of setups where some part of the manufacturing process, this guy in this, like in the end of the chain, he would be very beneficial from that quality measurement there and that recipe parameter there, but he cannot see that data. It actually can be connected to some platform, but he doesn't know, he doesn't get that data. Perhaps nobody even know in the organization that person would actually increase quality or efficiency with some sort of data set, especially for that action. So bring that data available so that people can themselves see that, okay, I actually in this operation, this works, I want that and that information to me to be more efficient and make those changes fast. So results needs to be happen. All right, when industrial data ops is needed, if you have more than one application, it's quite important and useful to manage the data for those applications as efficiently as possible. If you have evolving requirements, either like you are developing something, you are not sure what you are doing, or then your environment change or your material supplier change or whatnot in your business. So in this case, you need to have an agile way to kind of fulfill those changing requirements. If you have different kind of machines, lines, sites with different kind of interfaces, you can have, for example, emergency button. It might be emergency button, it might be E button on text-wise, or it might be a Boolean value 0, 1, and the other one is 1 and 0, etc. So in this case, you might want to normalize the E button. Actually, it's quite simple as function, but the data kind of notes that there is out for example, emergency button is surprisingly heterogeneous. And most important, involve team. People are doing this, so if you want to involve team, industrial data ops is very useful. What we use at Novotek, we use HiByte. You perhaps have heard about it. How many have heard about HiByte? Nice. We have actually a nice demo there. Hopefully you have been visiting. I think I'm not going to talk about maybe one thing here. We heard about unified namespace today. Not very much of it. I will have a few slides about what it is. But in here, I would like to just emphasize that unified namespace is not a single node. It can be a single source of information in your ecosystem, but it's not something that it should be like this every time. It should be serving your business needs and your environment. We heard about that it should be where data is. Definitely. We have to extend the unified namespace through the whole data infrastructure. But moreover, the normalized data needs to be here. It needs to serve the people who are on the plant floor making those decisions on a daily basis. So unified namespace is a set of normalized data and representative of the business in current state. It's not about historical data. Of course, you can move and utilize historical data, but it's more of the real-time view on your operations. And about the unified namespace. Many times we have heard this already, ISO 95 hierarchy, Purdue model of integrations. What I wanted to just emphasize that this is usually how the unified namespace is structured. So you have a site, line, asset, subsystem data. And this is the structure that is almost every time seen when we talk about unified namespace. Let's go back to the linear integration dilemma. We remember that this is slow and cost-wise not optimal. We have heard today about PubSub. So there is actually approach where each of these devices can publish their data and subscribe to the data that they want to have. Unified namespace is based on the PubSub method. It's based on the broker many times. MQTT broker, yeah, Kafka, yes, or data platform, yes, it can be there also. It can be extended through the information infrastructure, I would say. And the idea is here that in addition to, or as an alternative for this linear integration, you can have one engineer integrating that information into the unified namespace. You don't need so many layers, and the stakeholders here who would like to receive the data, they can actually then browse this unified namespace very kind of understandable way. This kind of folder structure that we have used everybody based on the ISO 95 structure. And it usually consists, of course you can build your unified namespace as serving as best for your business, but it usually consists at least 3 parts of information or 3 different kind of, I would say, type of information. One is descriptive. For example, asset. What is my fan type? Is it the radial fan or circulating fan? I might have some analytic services which requires this information. It might have the vendor information, this kind of descriptive information. In addition to that descriptive information, it usually has some functional information. For example, asset. What is the order of that asset? What is the functions of that asset? What it can be do? If you have SCADA topic for that, MES topic for that, depends on the business and what services you have for that asset. And then the third one is what we call use case topics, use case namespace. Walker Reynolds, if you have followed him, he called that informative, but we like to call it use case because it's usually something that is use case basics. We have a customer utilizing unified namespace, and I love the idea because they have actually citizenship development with one factory with, I think, 254 dashboard built on the operators themselves. They can go to the namespace, browse what they want. Okay, I want this. I will bring for this certain machine quality engineer, I have own dashboard. And that machine maintenance people have their own dashboard. They're utilizing the single source of truth of data so they can rely on the data, they can build their own dashboards. If the dashboards are use cases, then they are for use cases. That's okay. It doesn't need to be serving the whole organization. Of course, they have dashboards, data sets serving the organization. But the idea is that actually this unified namespace triggers the citizenship development, triggers the organization to get excited of the data, to use that data, to actually participate into that information infrastructure. From the dependencies point of view, I think it's a long day, so I will try to be very summarizing this. From this perspective, yes, there was a lot of connections, but this spiderweb of connections transforms into ecosystem of nodes. So you will have node that publish its information into the namespace, and of course can subscribe to the information that they are interested in. So this kind of linear industry 3.0, if you want to now I think they're talking about industry 6.0 in the marketing. But this is Celoid, it takes time, and how we see transformation from current situation to be actually really data-driven happens to this kind of broker architecture. It's not, then there is always, should I put every data there and should I put this and that? Well, that depends. Many times, nobody I have seen that have all data here. So be wise. Implement things that you want. Start from the most critical business cases. Don't try to kind of model everything. Just like said, see the use case. What is the most important use case and build that namespace, use case per use case. This is one picture where we have different kind of models. So you can model site, you can model line, you can model machine if you want for things that are common for machines, etc. So modeling, yeah. 3 minutes, yes. All right, so this is data vision that we believe in Novotek. We actually came up this like 3 years ago, but we believe that high quality normalized information should be available, all people, assets and processes to actually drive digital transformation. Happy to, please join to see the demo. We have industrial data ops and unified namespace demo on the deck. We have some kind of services there and topic structure. This is different because this is old. Thank you.